Something I forgot to add in at the end of the last video was the conclusion of that experiment, okay? So the conclusion of the experiment is just to say that sine I is proportional to sine OR. So when you, and you have to repeat for a number of different angles. Okay, so you repeat the experiment again and again, measure I, measure OR, and then you'll find out that sine I divided by sine OR is a constant, okay? So the next question was, a beam of light traveling from air strikes the surface of water. The angle of incidence is 36 degrees. The angle of refraction is 26 degrees. Use Snell's law to calculate the refractive index of water. Okay, lovely. So all along I've been saying that sine I divided by sine OR is a constant. Well, that constant is n, which is the refractive index. Okay, so I can do sine of 36 degrees divided by the sine of 26 degrees. Let's jump back and double check that that's what it is. Angle of refraction. Yeah, okay. So I'll get my calculator and I do sine 36. Am I in degrees? I am. Making sure I'm in degrees, not radians, divided by the sine of 26. And I get an answer of 1.34. Okay, there's no units on that because it's just a ratio of speeds of light in air and in water. Refractive index can also be calculated using the formula n equals 1 over sine c. What does c stand for in the formula written above? Okay, so in the formula where n, the refractive index, is 1 over sine of c, c is the critical angle of the material. So that's the angle that if it's passing from the material into air, and if it's at an angle greater than the critical angle, then it will bounce back and you will get total internal reflection, the critical angle of the material. All right. A converging lens refracts light. Copy and complete the diagram below to show the paths of the rays of light after they strike the converging beam. Okay, so we have a lens like this, and then we have light that's coming in parallel to each other like this, and then all we need to do is draw it all towards one specific point, and that it's a bit messy looking now, but you get the idea that they're all going towards one specific point. Let's have a look at the marking scheme there. Yeah, they continue them on out so that you see them traveling. Hang on, I'm gonna do this better. So we get, that's the right thing. All right, so there's my lens. Okay, I got light, light, light. So there, 1, 2, and 3, like that. Okay, and then this point here is F, the focal point of the lens. All right. A converging lens can be used to produce a magnified virtual image. Explain the underlined term. Okay, so a virtual image is formed by, this is an important word here, the apparent intersection of rays of light. It cannot be projected onto a screen. Only real images can be projected onto a screen. Okay, so it can't be projected or formed on a screen is another way to look at it. Okay. All right. I will leave that there and record another one in a moment. Where's my recordings gone?